Hi there, welcome to my channel. So today we're gonna look at merge sort. So it's a pretty heavily used algorithm, and it's very efficient at sorting, and you're gonna probably have to implement it in your CS classes and CS journey at some point. So it's definitely not the easiest algorithm to implement, but it can be pretty straightforward if you know what it's actually doing and stuff. So in this video we're gonna look at the implementation part, but we're definitely gonna dive into it like in other videos. But in this video we're just gonna briefly explain like how merge sort works, and it utilizes the divide and conquer procedures. So that's how we do it. We have two functions in this sorting algorithm. Of the main function that merges, that divides the elements into two separate arrays, and it keeps on dividing it. And then we have the merge function that combines it back into a single array, and yeah, it returns the array back to sorted array. So we're gonna go to the whiteboard and we're gonna check how it works briefly. So first of all, we have these elements, so 5, 4, 3, 2, 1, to keep it simple. Now we're gonna have midpoint. We're gonna have a midpoint, and it can be anything, but we're probably gonna take it as array length divided by 2. We're gonna see how we implement it. So let's say it's this element right here, and so basically we're gonna divide the array into two parts. So it's gonna run. So let's say we divide it into these two arrays, 3, 2, and 1, and then again, let's name it left array and right array, and then we can divide this left array into two more arrays, right? Like 5, 4, and 3. Sorry for the bad handwriting. And 2 and 1, exactly like how we did the other one. And so these have reached their base cases, which is like unless they reach like one element in an array. So like the base case is if the array.length hits 1, then we're just not going to divide it any further, right? So we're going to now try to merge them back. So now let's do this for this. It's 5 and 4. So now that each and every one of them have reached their base cases, we're gonna combine them back, and we're gonna compare the elements, and then we're gonna merge them back by using a merge function. So we're gonna compare these two elements, and 1 is definitely smaller than 2, so we're gonna add 1 first, and then 2 first, then after that. Then we're gonna do, so you can see these are still sorted, and then 5 and 4, so we're gonna add like 4 first, and then 5. Then we're going to compare the other elements. Then it's going to be like 3, 4, and 5. Then we're going to do compare these two. Then it's going to be 1 first, then 2, then 3, then 4, and 5. And then we're going to get like 1, 2, 3, 4, and 5 as a sorted array. So it's pretty simple. You first recursively call the function to break the elements into smaller elements until they reach the base case, and then you merge them back. So we're gonna now look at how we can implement it. So let's come back to our compiler, and we're gonna just have the same group of elements for 3, 2, 1 again to keep it simple. And we're gonna have the main function in here, public static. It's not gonna be void because it's gonna return back an int array, and we're gonna call it merge sort, and it's gonna have an argument. It's gonna take an argument of an array of integers, and then we're gonna find the midpoint. Int mid equals array.length divided by 2, and then as we talk, we're gonna have left and right arrays. So we're gonna initialize them. Left equals to new int mid, and int right equals new int array.length minus mid. So why we did this is like we basically subtracted the whole array and like the length of the left array from the whole array to get the length of the right array. So this is just in case like there are odd number of elements in the array. So yep. Then we're gonna input the elements from the array to the left and right array. So we're gonna push the elements there. Now, so we're gonna divide them, distribute them, whatever you want to call it. So let's have two loops for that. Dot left dot length plus. So left I equals to array dot I. So this is simple. With the other one, it's gonna be a little bit different. It's also gonna be pretty simple, but just a little bit different. We're gonna implement it differently. So obviously we're gonna put it to the right array, and we're gonna add mid to it. So it stays in a sequential manner. So because it does, so starting from 0 doesn't like make sense for array because we already added them into the left array, you know. So we're gonna have to add the mid to it, or we can also add like left dot length. It doesn't really matter. So we're just adding the length of the left array. So it basically starts from that element from like of the array. So it doesn't overlap, you know. So that's what we're doing. And now we're gonna create a new. Actually, we can do that later, but we can do it right now. It doesn't really matter. But now we're gonna break down the left and right array by using recursion. So the left array is gonna call itself again and again until it's broken down, and so is the right array. What I mean by broken down is until it's broken down to a single element. So we're gonna have the base case on the top. I've not yet coded it, but we're gonna do that. Then we're gonna just have an int array of result, and it's gonna have the length of array.length. And then we're gonna have the result array have the merge element. It's gonna take. So we haven't coded the merge function yet, but we're gonna do that later, like after this. So then we're gonna return the result. So basically, we're gonna create a result array, and then the result array is gonna have elements that have been returned from the merge function that will take the left and right array as an argument, right? So that's what's happening. So when we code up the merge function, we're gonna understand what's happening. But before that, let's code up the base case, which is if array.length reaches 1, we're gonna return the array. So basically, it's pretty simple. So once the arrays have reached to the base case, which is reached to an element of 1, it's gonna return itself. So there is no point in breaking it down any further. So that's why it's gonna return, and then it's gonna like merge itself, right? So now we're gonna code the merge function. So same thing again, static int array. It's gonna also return an int array, and let's call it merge, and it's gonna have two arguments, int left and int array of right, and let's code it up. So let's code up the resulting array. It's also new. Sorry, it's gonna have this new int, and it's gonna be the combined length of both of them. You know, the length of right and left. So now we have this setup. So it's the result array, and it's gonna have it's gonna merge those two arrays, but we're gonna compare them and then merge them, right? So now we can initialize some pointers to traverse through the arrays, and we can have int I equals 0, int I, and j equals 0. I'm gonna add commas, not semicolons, and 0, and then we have it. And we can also assign the length of the arrays into an integer variable. So dot length. So this is just to make it a little more simpler. So these contains the length of those two arrays, so nothing fancy. So now so we gotta focus on this part. So it's pretty important. So while I is less than I is for we're traversing the left array, by the way, and j is for traversing the right array. So just so you know, and j less than or I, we're gonna do these. So this basically is saying that until one of the pointer reaches the last, breaks out and reaches the last element of the array, we're gonna do these things, right? So if left I is less than or equals to right I, j is for traversing the right array. So we're gonna have result k++ equals left I++. So we basically upgraded the counter because we're gonna have to upgrade it, obviously. So it's pretty simple. And then I'm gonna explain it later if it's hard to understand. But otherwise, we're gonna have result equals right j++, because j is again the pointer for the right element. And so yeah, what it does is basically it's looking if I has reached the left, like all of the elements in the left array, or either j has reached all of the elements in the right array. If not, then we're gonna do these stuff. So it's basically comparing the elements, you know, as I showed you, like it's gonna compare these two elements, then it's gonna put the lower element into the array first, and then it's gonna put the bigger element. So basically that's what's happening. So if this element, the left I, is lesser than the right j, put the left element first, or else if the right element is lower than the left element, put the right element first. So that's what it's doing. But we still have two cases to handle. Not two cases, actually it's one case, but we're going to have two statements to handle the single case. Now one of the pointers is going to break before the other. So it might or it might not. It's most probably it will. And so take care of the remaining elements. We're just going to have to basically make a loop that takes care of the remaining elements, right? So for that we do this. So while I is done left, basically have this done equals to left plus plus. It's very simple. While j is less than right plus k plus plus equals right j plus plus. Return result. So what we did in here, let's go through the merge function, okay? So we initialize, we take left and right array as an argument. Then we initialize a result array that is of the length combined of left and right array. And then we initialize the length of both array into two variables. So we can do that, we don't have to do that. It's just keep it simple and to keep it tidy. We did that, and then we initialize some pointers, I, j, k, to traverse. So k is for traversing the result array, apparently, as you can see, and I is for traversing the right array, the left array, and j is for the right array, right? So then we have this while loop, so until one of the pointer reaches the last element and it breaks off, we're gonna do these stuff, which is comparing the elements and putting the right element at the right spot, right? So result k++ equals left I++ if the left array, the element of the left array is less than the right array, or else we're just going to put the right array, and then we're going to basically increment the counters. So that's why we did this. We can use it, you can do it in the trivial way, in the naive way. You can just do result k equals left I, then k++ and I++, but those takes more lines of code, and it's less elegant. And then we're taking care of the remaining elements by doing these two while loops. So while I is less than left, left.length, basically. Result k plus plus equals left, k I plus plus. I is used for traversing the left array, and then while j is less than right, I've named it funkily, so it's hard to pronounce the variables, but anyway, you get the point. Result of k plus plus equals the right j plus plus. So it's basically taking care of the remaining elements, so in case like one element breaks off before the other. So then we're gonna just return the result array, and it's gonna come here, it's gonna merge itself, it's gonna recursively call itself until it's fully sorted, and then it's gonna return back the sorted array finally here. So let's see if it works or not. It might have some bugs in it if some things might have not properly been implemented, but we're gonna take care of that. So because it sends out an array, we're gonna have to print that array like this. And I hope you're understanding what I'm doing. I'm just using the toString function of the arrays that is offered by Java. It might not be in your language, but so yeah. So as you can see, it returns the sorted array back, so we know it's working. And we can just have a little check for duplicate elements. So we just did this, and we're gonna run this, and let's see, and voila, it works for duplicate elements too. So let's go through everything once again, just briefly. So we have two functions. The main function, the merge sort, which takes care of the partitioning algorithm. So it's basically recursively breaking down the elements into pieces until it reaches one length of 1, and then we're merging back them using the merge function. And that is basically comparing the elements and putting it back to result array, and then the result array is being returned, and then again it's being recursively called, so it completes the process and builds up the sorted array, and then we get the sorted array back. So I hope it was pretty straightforward to understand, and well, I acknowledge that it might be a little bit difficult for beginners to understand, or even we might be intermediate and might have trouble with it. But if you have any kind of doubts, leave them in the comments. And if you found this helpful, just leave a like, drop down a comment, and share this video with your peers. And yeah, see you next.